Now in this section, we'll try to understand the loop prevention mechanism in the multicasting. We call it as a reverse path forwarding check. Now reverse path forwarding check is used to eliminate the loops which may occur when your router floods the multicast traffic. Now the PRIM protocol we use here, like here in this scenario, normally the PRIM protocol is used to advertise the multicast information. Now there is a possibility that now the video server here is sending out the multicast traffic to the receiver here. Now there is a possibility that you are receiving the multicast traffic from multiple sites. Now how the router is going to figure out from where it has to receive the multicast traffic, where it should not receive the multicast traffic. And that is something decided based on the RPF check. Now whenever a router receives a multicast packet, it is going to look at the source IP of the packet. Now in this scenario, let's say the router 1 is receiving the multicast traffic from video server 10.1.1.1, that is the source address, and then it's going to see the outgoing interface. Now here it is receiving the multicast traffic from both S0 by 0 as well as it is receiving from S0 by 1. So it's going to see the outgoing incoming receiving interface from where it is receiving, and then it is going to check the normal routing table. It's going to see the routing table, show IP route, and it's going to see that to reach the 10 dot network, what is the best route, the shortest path to that particular best route. Let's say in my scenario, this is the shortest path. Now in your routing table, you'll see that it goes via S0 by 0 is the best path. So probably what it is going to do is it's going to receive the multicast traffic only on this interface, whereas RPF check passes here because the source to reach that multicast server, it's going to check the reverse path and it is matching the entry here. And when it is receiving from the other side, it's not going to match here because according to this is the best route to reach that server, and that's what you see in the routing table. It's going to receive the multicast traffic only on this interface, whereas on the other interface it's going to discard the particular packets. So that's how the RPF is going to on the multicast routers are going to figure out the loops, and it will only receive on the interface a multicast packet which passes the RPF check. Now to practically verify this behavior, we'll go to our lab which we are done in the previous scenario. In the previous we configured something IGP here, and then we have enabled IPPM dense mode on this interface. So what I'm going to do is we have already generated a traffic from the R1. On the router 5 we have configured a join group command 224.5.5.5. So let me quickly show you the basic setup or the configuration what we did already here. Now on all the routers, if you verify show IP OSP of neighbor, I have IGP configured, that's the first step, and then I have also enabled with IPPIM dense mode. So if you verify show IPPIM neighbors, you will see the neighborship is up. On all the routers, dense mode is also pre-configured. So that is something I did in the previous lab. If you go through with my previous videos, you will find this configuration information. Now the third thing, on the router 5 interface F0 by 0, we have configured a join group command, IP IGMP join group command, where we are simulating the host who wants to receive the multicast traffic. So show run interface. Now the command is IP IGMP join group command. Now we are simulating the server on the router 1, and we'll try to generate a traffic from router 1. We'll try to ping to that multicast address. You should see the reply if everything is okay. And now we'll try to verify the RPF check. Let's go to router 5 here. If I give show IP mroute here. Now mroute for 224.5.5.5, that is the multicast group address we are using here. And you can see here I'm receiving the multicast traffic from 4.4.4.2, that's the source, and it is receiving on S1 by 0 interface, right? It's receiving an S1 by 0 interface, and the router is going to check the routing table, show IP route 4.network or 4.4.4.2. It should match the exit interface on S1 by 0 incoming interface. So once it matches, it's going to receive the multicast traffic. Now that's okay because you just have only one interface here, but what if we go on the router 4? Now on the router 4, if I give show IP mroute, to verify the RPF table 224.5.5.5. Now here you can see I'm receiving the multicast traffic from 4-door network. In fact, it's coming from 4-door network as well as it's coming from here, from 1-door network as well. Now here the incoming interface from 4-door network is S1 by 1. This is S1 by 1 here. And it's going to verify this incoming interface has to match show IP route. So if I say show IP route OSPF, it should match that particular 4-door network. In fact, 4-door network is directly connected. It's directly connected on S1 by 1, I think here. 4-door network is on S1 by 1. So which means it's going to match the routing table and this one. So the interface, it is receiving the multicast traffic, and to reach that particular server, it's matching. So it's going to receive the multicast traffic on this interface. But whereas if it's still receiving the multicast traffic from this particular source, it's receiving from this side as well, but it's not installed in the multicast routing table because this is the shortest path here. So this is how it's going to prevent the loop in general. Now to further verify, what I'm going to do is, I'll go to this router 1 and router 4 interface. I'll remove the dense mode here. Now this interface, I'll remove the dense mode here. Now that will automatically make your RPF to fail. Let's go to router 1. That's what I did in the lab workbook as well. If you just go back here, I just disable this interface here, or you can try trace also. I'll go to router 4, interface S1 by 1. I'll say no IP PIM dense mode. So I'm going to remove the dense mode on router 4 interface. Now if you go to router 4, if I give show IP mroute, so if you go and verify show IP mroute for 224.5, you should see that 224.5.5.5. Now you don't find any entry here. You don't find any. Here you can see incoming interface is null because it is not receiving it is not actually. Now let me generate some traffic here. So if I try to ping now, I should not see the reply here. If I just repeat it multiple times, I can see I'm not able to get a reply from 224.5.5.5. Now the reason here is the router 4 is receiving the multicast traffic from 1.1.1.1. Its incoming interface is null. Now the incoming interface is null, and the reason is, if you verify show IP route OSPF, now the 1-door network is received on 1.1. Now here you can see, if you just check here, it's receiving the multicast traffic from 1.1.1.1. It's receiving from this side, but not from here, because this interface is not enabled with dense mode. So which means this interface is not multicast enabled. So we are receiving the multicast traffic from this side 1.1.1.1, and it's going to check it's going to do some RPF check, and in that RPF check, the interface where it is receiving on S1 by 0. That's the receiving interface. It has to match the routing table to reach 1-door network. Now to reach 1-door network, what is the path here? It's S1 by 1. Now according to the routing table, to reach this 1-door network, the outgoing interface is S1 by 0, but it is receiving the multicast traffic from S1 by 1. So it's not matching. So if it does not match, it's going to, your RPF check will fail. So it's not going to receive the multicast traffic on that port. It simply drops the multicast traffic even though it receives from here. Now to fix this, either you need to ensure that your IGP path used by the routers, it should be the best path, and that best path should have a multicast enable. That is one possible solution. That's something you need to keep in mind. Or we need to change the IGP calls to go via this route. This should be the best route. That is one more way to figure out this. Or we can manually configure the multi-static route, M route, we can say, to fix this one. There are multiple ways to do this. Either you can shut down this interface. If you shut down this interface, automatically it matches. Let me try this. So you can see if I shut down this interface, if I give the shutdown command, now this interface will be down. So to reach this 1-door network, This will be the best path, and you are also receiving the multicast traffic from this interface, so it's going to match. So then you can see the reply. So that is one possible solution you can go with. Or you can manually configure a mroute command, because in some scenarios you may not running multicasting on this interface, but this will be the shortest path to reach the multicast source. So in those kind of scenarios, we can configure a mroute commands. There is also one possible solution. You can go ahead with that one, or the other way, we can even change the IGP cost also. So in general, we can go with any one of this solution if you come across this scenario. But when you're doing some troubleshooting, let's say from the router 1, you are not able to ping to this multicast group address on the client side, probably you need to check the RPF check. So you need to ensure that your RPF check should work fine. Now, if your RPF check fails, probably what you will see is, if you give show IP mroute, you'll find the incoming interface null normally. So you'll see something like incoming interface is null. So whenever you generate some traffic, now you don't see the entries. Let me generate the traffic first. And then if I give show IP mroute, I can see incoming interface is null. So it's receiving the multicast traffic, but it's ignoring on this interface because of the RPF failure.